Morning, students.
Afternoon, sir.
Good afternoon.
Afternoon, sir.
Good afternoon. Shall we start?
Yes, sir.
Okay, right. So we have seen different types of power amplifiers and what are the heat sink and the types of heat sink, how to mount the heat sink on a power transistor, and we also seen what are the different working principles of different power amplifiers. So now we have gone to the second part of your third chapter, which is tuned amplifiers. So, what is the tuned amplifiers? The name it's having the meaning that it will the amplifier which will purpose of tuning. That means you can change the frequency range. You can change the frequency range and you can also amplify the that frequency range. So you can change the frequency as well as you can have to also amplify that frequency range. So tuning purpose, the amplifiers which are used for the tuning. So that is tuning means in order to change the frequency range. So there are the two types of tuned power amplifiers, or you can also call it tuned amplifiers or tuned power amplifiers, both are same. So you have two types of tuned power amplifiers. What are they? Small signal tuned power amplifiers and large signal tuned power amplifiers. Okay, so in a small signal tuned amplifier, it will amplify the signals, very small signals. So the signals which are used here are amplified every weak signals. The voltage levels are very less at radio frequencies. You have to remember this. So tuned amplifiers have the range of frequencies in the range of radio frequencies. Okay, in the order of kilohertz. In the order of kilohertz. So 10 kilohertz, 3 kilohertz to 30 kilohertz. The normal range, and 30 to 300 kilohertz. So it is the high range of RF frequencies. The low RF frequencies and high RF frequencies. So 3 to 30 and 30 to 300. Okay. So and the power involved in the small signal tune amplifiers is small. Okay, so and that is the reason they are used for the purpose of amplification, and the amplifier used is the class A power amplifier. Okay, so class A power amplifier is used in the small signal tuned power amplifiers, and the radio frequencies range also small. Okay, the range of frequencies in the small range RF frequencies are a less low RF frequencies 3 to 30 kilohertz. Okay, and the power involved is large in the case of the large signal tuned amplifiers, and it is operated in under class B as well as class C power amplifiers. So hence the distortion is also large in the case of the large signal tuned amplifiers. Okay, and you can say that. Okay, so we have We have small signal tuned amplifiers and the large signal tuned amplifier. In the large signal tuned amplifier, you are dealing with the large powers, and the operation of amplifiers in the large signal tuned amplifier is class B as well as class C. So whereas in the case of small signal tuned amplifier, we are dealing with the small powers, and the power amplifier used is the class A power amplifier. You are dealing with the high amount of powers in the case of large signal power tuned amplifiers. So what will happen? The distortion is also more in the case of the large signal tuned amplifiers. The distortion is small or negligible in the case of class A power amplifier. We already see, because a class A power amplifier is a small signal amplifier or a voltage amplifier. Correct or not? So automatically what will happen? The distortion is also less. Okay. So, and the small signal tune amplifier again further classified into three types. So what are they? Single tuned amplifiers, double tuned amplifiers, and stagger tuned amplifiers. Okay, is it clear or not? There are three types again: the small signal amplifiers, the small signal tune amplifier, or small signal tune power amplifiers, classified into again three: small single tuned amplifiers, double tuned amplifiers, staggered tuned amplifiers. So in the single tuned amplifier, what will happen? So the tuned circuit is a tank circuit. What is a tank circuit? Means L and C, parallel combination of L and C. So what is the L? Inductor and the capacitor. The parallel combination of the L and C will used only single. That means only one tank circuit or one tuned circuit is used as a load in the case of a single tuned amplifier. In a double tuned amplifier, we are using L and C components, and they are two two LC circuits or two tuned circuits or two tank circuits are used in the case of the double tuned amplifier as a load. And the staggered tuned, you can change the frequency range by changing the L value or C value. Most of the times the capacitor value changes. The staggered tuned amplifiers, the tank circuit or a tuned circuit which is changing the range of frequencies by changing the capacitance value. That means you are using a variable capacitor, the variable capacitor, and they are cascaded or successive tuned circuits are used in the staggered tuned amplifiers. Is it clear? In a staggered tuned amplifier, uses number of single tuned stages in cascade or successive tuned circuits. Okay. So this is the difference between the three circuits or three classifications. So what is that we have is, so if you see in the frequency response of any tuned circuit is like this. Okay. So what is how it is looking like? It is a bell shape. So it is a bell shaped circuit. The frequency response. What is the frequency response? It is the response. It is the characteristics drawn between a gain and a frequency, and the frequency response is like this, and it is at a resonance. The voltage gain, it is peak voltage gain we are getting. That frequency you can call as a resonance frequency. If not, at a peak of the voltage gain AV, you will get a some frequency that is constant. That will you can call as a F naught or resonance frequency, that is given by 1 by 2 pi under root LC. That means the resonance frequency is
ఏమైంది?
depends upon the L and C components. Okay. And what will happen at the resonance frequency? The impedance, the ZP, you can call it the parallel impedance ZP.
నేను
Is
భయపడ్డాలే.
is it clear? The parallel
ఘోరంగా భయపడ్డాను.
impedance is, yeah. Okay, at resonance frequency, the parallel impedance is the high, and it decreases with the frequency changes over the resonant frequency. Okay, so this is the characteristics of the any tuned power amplifier or tuned amplifier. Okay, it is bell shaped, and the voltage gain is peak, and there you will get a peak voltage gain. You will get some frequency you can call as a resonance frequency, if not, and it will depends upon the L and C components, L value, changing the L value or C value, you will change, you can also change the F naught value. Okay. So if you see the circuit diagram for a tuned, single tuned power amplifier or single tuned amplifier circuit, so what is it will resembles is, you can see it is a common single stage RC coupled amplifier, correct or not? A single stage CE amplifier, it is a resembles like a single stage RC amplifier, single stage CE amplifier, correct or not? What is the difference? Only difference is this load. The load is replaced, RL is replaced with the L and C parallel combination of L and C. This is called a, you can call as a tank circuit or tune circuit. See here, the variable capacitor, the capacitance value changes, F naught also changes. Okay, is it clear or not? Very simple to understand. So the circuit diagram is very simple. Okay, easy to understood, because the circuit we already seen. Which is CE amplifier. What is the difference? Only RL. So in the place of RL, you are just placing the load as a LC circuit. So what is LC circuit? Parallel combination of L and C circuit, which is a tune circuit, or you can also call it tank circuit. Why it is tank circuit? Means the energy is transferred between L and C to L. The energy is oscillating. The energy is oscillating between two two components, energy saving components or energy stored component, L and C. So that is the reason it is a tank. It's like a tank. So energy is saving, it is storing the energy, so it is a tank. So it is a tank circuit or a tune circuit. Okay, so if you see in the construction, what will happen? So same thing. So what is that? R1, R2, RE and C will provide some biasing. Vs is the input signal, V0 is the output signal, which is taken across the RL, and it is connected at the, what is that? It is collector. So where you have taken at the collector, you are taking the output. So VCC is connected as a power supply. So in the circuit operation, if you see, what is the circuit operation is, so what is the circuit operation? If you see in the circuit operation, the same as that of your C amplifier. So what will happen? What is the purpose of the transistor or transistor action? What is the transistor action? It will it will it will amplify the small signals. So in a single tuned power amplifiers, what is the small signal amplification is taking place? We already discussed the single tuned amplifier is the under the category of the what is that? Small signal tuned amplifier. The small signal tuned amplifier will always amplify the weak signals. So it will dealing with the small voltage levels. So the small voltage level which is given at the Vs, that is amplified by using the transistor tube, and is given at the this point. What is this point? It's a collector. So this point will be given at the load. So what is this? This is, now it will be generate, it will oscillate the frequency range. So it will have the two purposes. So L and C components will generate a different frequencies, and also it will amplified. So it will generate a frequencies of desired frequencies with the amplitude version of amplifying the input signal. Correct or not? It will amplify the signals of desired frequencies. So desired frequencies are the range of frequencies. It is amplified by using a single tuned amplifier circuit. So very simple. The LNC circuit will generate a desired frequencies or required frequencies. Okay, for the range of different frequencies. So and what is the doing this amplifier transistor? The transistor is doing its transistor action. What is the transistor action? It will amplify the weak signals. So whatever you are connecting the single tune amplifier, which is a small signal amplifier, which you amplify the weak signals. So and it will generate just some frequency, you can call as a resonance frequency. So that resonance frequency, so and that resonance frequency is amplified. So the at the peak levels, you can see the characteristics we already seen. So in the resonant frequency, we have a some voltage levels. So voltage level, which is you can call as the voltage gain AV. So in that voltage gain, in that voltage only it will be amplified more. Correct or not? If not only, it will be amplified more. And the other frequencies are, it is not amplified that much. That means it is amplified is decreases. Amplification is decreases in the other than the other than the F naught. So if you more and more the frequency is reduced. That means resonance frequency is reduced means it will compact. That means the bell shape is very compact. That means only the F naught only it will be only it will be raised. Only F naught will be it is amplified. Means you are generating a narrow band with narrow band amplifier. So generally the all tune amplifiers are narrow band amplifiers. So the frequency is very small frequencies only, very narrow frequencies only it is amplified. So at a general area or a general or particular area of frequencies only it will be amplified. So it is called a narrow band amplifier. So all tune amplifier are narrow band amplifiers. Okay. So and it will reject all other frequencies. So at a particular frequency you can call as a resonance frequency. That frequency only it will be raised or voltage levels are increased. Other frequencies or it is rejected. So that is you can call as a narrow band amplifier. The frequencies at which you can amplified or more energy you are giving, that is a narrow band amplifier, and the other frequency it will be rejected. Okay. So band reject filter you can call as a band reject filters. What is the band reject filter? The frequencies below which, above which, and it will be rejected, and at a particular frequency only it will be amplified. So narrow band amplifier or band reject filters are tune amplifiers. Okay. So is it clear? This is the operation of the single tuned amplifier circuit. So what is the operation? Whatever the type, what is the type of amplifier you are using in this power amplifier you are using this circuit? Tell me, what type of power amplifier you are using in the single tune power amplifier? What is the mode of operation? Class A, class B, class C, what is class D? So what is the mode of operation used in the single tuned? If you see in the circuit, what is the
Class
operation?
A, sir.
Class A, it is a single tuned amplifier. Small signal amplifier used class A power amplification. C amplifier is the same as that of a class A power amplifier. Correct or not? All are same. So what is the purpose of this R1, R2 and RE and C? For the purpose of biasing and stabilization purpose. So and what is the transistor action? It will amplify the input signals, weak signals. So what is the purpose of LLC component here? So it is a tuning purpose. What is the tuning? So you have to generate the resonance frequency and rejects the all other frequencies. So you, by changing the C value, you will change the F naught value. Okay. So at a particular frequencies, in order to select some particular frequencies, you are using a tune amplifier mainly in the communication purpose, mainly in the communication receiver. In the communication receivers, we are using a tune amplifier because there are, in the transmitter side, you can transmit any type of signals in the wireless communication. Okay, but in the receiver side, only your particular frequency only you want to accept, and the other frequency you want to reject. Correct or not? For example, in the FM radio 108.8, for example, 103.8 FM radio, if you are there, but in the wireless communication in the environment, we have a different types of signals. 98.8 FM and 97.8 FM. Like this, so many FM signals are there. So, but you want to read only 103.8 FM signals. Then what they do? They will select a particular frequency by selecting the F naught or resonance frequency by changing the particular C value. Okay, by changing the C value or capacitance value, you can easily select a particular frequency like 103.8 FM. So their purpose we are using it single tuned power amplifiers or attuned amplifier circuits. So okay, all tuned amplifiers are selective in nature. So the narrow band amplifier or selective filter or a band reject filter, all are same. Whatever you are saying is the same terminology. The concept is same, but the construction may be different. But you have the concept is overall concept is same. Narrow band means the width of frequencies only it will be amplified. All other frequencies rejected. So selective filter also same. It will select this particular frequency and reject all other frequencies. So same thing, same as it is in the tuned amplifiers. So you will see the tuned amplifiers used in the all communication receivers. All communication receivers should contain this tuned amplifiers. Okay, so this is the single tuned amplifier. You can also draw like this also, there is no problem. Okay, so single tuned is also you can draw like this. Okay, so what is the difference here is you are coupling with the other inductor. So mutual coupling is there, it is single coupling. Okay, it is single coupled, it is the mutual coupled, there is no problem with this, because the inductors here transformer you are using here, it mutual induction method. In the output voltage you can transfer from this windings to primary windings to secondary by mutual induction. So you can draw both ways, there is no difference, there is no, can draw both ways. So there is no difference in the first circuit and second circuit. First circuit is only LC tank circuit. In the second circuit we have a transformer. So transformer is also inductor. Okay, inductance in nature. So you can draw it the both ways. So the same thing you can also draw the double tuned amplifier. So what is the double tuned amplifier circuit? So there are the two tuned circuits. So L1 C1 and L2 C2. Is it clear? So if you have a two tuned circuits in the load, two tank circuits or two LC components or LC parallel circuits are there in the load, you can call it as a double tuned amplifier circuit. So the working is same, but the frequency components L1 C1 and L2 C2. So frequency you will be varied by changing the C1 value as well as the C2 value. Okay, there you can only change by using C. Here C1 and C2 you can change. You can change the frequency value f f naught. So the resonance frequency depends upon the C1 as well as C2. So most of the time the capacitor only it will be changing. The inductor also you can also change, but the inductors changing with the variable inductor is the bulky in nature. Size is more and cost is also more 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 efficient. So that is a not efficient way of your variable inductor method. Okay, so it is a more efficient way of changing the frequency is by changing the capacitor value only, because the inductor is bulky and size is high. So this is the reason most of the time they will use the capacitor to change the frequency. So and what is the main purpose of this double tune amplifier is, so it having, why we are going for a double tune means you have a high selectivity and high gain and high bandwidth, and for a double tuned voltage amplifier circuits. So it is a voltage amplifier only or class A power amplifier, correct or not? So if you are having a these qualities, you want to these qualities, high selectivity, high gain and high bandwidth, so you go for a double tuned power amplifier circuits. Okay, so this is the operation. What is the operation? I already said. So same as that of your single tune amplifier. So what is the operation? Whatever the weak signal you are given to the transistor, that is given at the output of the collector, and it is given to the tank circuit or tune circuit. There, the amplify the only the signals which are operated in the resonance frequency only, it will be amplified. Okay, all other frequency it will be rejected. Okay, so this is the concept of single tuned double tuned power amplifier circuits. Okay, so what is the tune amplifier? Tell me one. What is tune amplifier? What is the tune amplifiers? Tell me.
It amplifies particular frequency signals.
Very good. So it will be tuning a particular frequency and rejects all other frequencies. So selection purpose, in the purpose of the selecting a particular frequency, we are using tuned amplifiers. So they are also called narrow bandwidth amplifiers, narrow bandwidth amplifiers. Okay, selective filters. Okay, you can also call selective filters, selecting the particular frequencies. So what are the major applications of the this tuned amplifiers? What is the purpose where we are using this tune amplifiers mainly? All communication receivers, transmitter as well as receivers. So in the receivers they are using
FM
mainly,
radios, sir.
in the receivers they will use a tune amplifiers. Also FM receivers mainly, AFM receivers, all FM receivers contain tune amplifiers. Okay, so what are the different types of tune amplifiers?
Two types, sir. Small signal,
Two
large
types:
signal.
small signal tuned amplifier, large signal tuned
Very good.
amplifier.
What is the main difference between these two, small signal and large signal tune amplifiers?
Small signal amplifies, small signals, sir. Small signal power tuned amplifier.
Yeah. So it is deals with the small power levels in the case of small signal. Well, in the case of a large signal power amplifier, it will deals with the large powers. Okay. So what are the different types of small signal tuned amplifiers?
Single tuned, double tuned, and stagger tuned amplifiers, sir.
So what is the
Staggered.
meaning of staggered tuned? What is the meaning of staggered tuned?
Number of signals
Uses
tuned
the number of signals
cascades, sir.
So the number of single tuned amplifiers cascading manner. You are connecting a series of single tuned amplifiers as a load. So you can call it as a staggered tune, and there staggered tuned, the variable capacitors are used to in order to change the frequency or resonance frequency. Okay, so this is the difference. So today, this is the today class. So I will wind up the class, and I also post the video lecture. You can also see in your WhatsApp. Okay, right. Thank you. Thank you all.